Yeah. So, good afternoon. I welcome all the students registered with this course, Applied Thermodynamics, and those who are attending this session, to this live session. The course Applied Thermodynamics is an important core course to the students of mechanical engineering, electrical engineering, chemical engineering, and civil engineering. Of course, students from aerospace engineering also need to learn several applied aspects of thermodynamics. In this course, we have discussed several topics of applied thermodynamics, starting from the description of basic laws of thermodynamics, their applications to several processes, essentially to estimate their thermodynamic performance or thermal performance. Thereafter, we have discussed about steam power cycles, then internal combustion engine, gas turbine cycles, and refrigeration cycles. In particular, in this course, I have discussed about the steam power cycle. If you have any questions from that particular module, I'm pretty sure that by this time you have completed that particular module. And any questions from that particular module, if you have, kindly raise your question in the chat box. In that particular steam power module, we have tried to discuss about the if you have any questions from that particular module, if I can recall correctly, we have discussed about combined first and second laws applied to several processes, several components in a steam power cycle, identifying whether the component is heat interacting or work interacting device or component. Then, if we need to know about the work done by the process or heat transferred into the process, to know all these, we had discussed about the application of combined laws. Then we have also discussed about cycles, rather thermodynamic cycles, which are used to describe or map all the processes in a steam power plant. Then we have also discussed about several modifications which are there to improvise the efficiency of steam power plant or steam power cycle. Then also we have discussed about the steam generators, flow cycles inside the steam generator. And from there, we have also tried to estimate the efficiency process that takes place across the turbine, certainly steam turbine, we have discussed, and then we have tried to know the efficiency of the turbine. If you can recall, in a steam power module, there are 4 major components. Those are steam generators, steam turbine, cooling tower, and feeding pump, boiler feed pump. So in these, there are many other components, but these 4 components are the major components. Turbine is a work interacting device from where we get work output. And we have discussed the process which is taking place across the turbine. We have mapped the process that takes place in the turbine in thermodynamic planes like PV-TS plane, and from there we have estimated the work output. We have also discussed another essential component, that is flow nozzle, which is an integral part of the turbine. And when steam flows through the flow nozzle, essentially the objective is to enhance the velocity of the moving steam at the cost of some enthalpy drop. So we have analyzed the steam flow through the flow nozzle, and we have also discussed several facets related to steam flow through a nozzle. Then we have also discussed about the cooling tower, because in a steam powered plant, we need to recycle back the steam, which is, or the steam that comes out from the turbine, in a place or in a device, and the device is known as cooling tower. So cooling tower is essentially a heat exchanger in which the collected steam from the turbine is taken through the cooling tower, and cooling or cooled, or any coolant is typically, it is cold water, is supplied across the cooling tower as well. So cooling tower is a sort of cell and tube type heat exchanger, and releasing certain amount of heat to the cold water, steam get condensed, and we pump back that condensed or collected condensate from the cooling tower to the boiler pressure. So for that we need a pump, and we have also discussed about the pump. So for a successful operation of a cooling tower, we have also discussed several technical aspects, whether the cooling tower should be operated below atmospheric pressure or not, and then what are the possible problematic issues to run a cooling tower. We have also solved a few numerical problems illustrating the conceptual part of several components that we have talked about. Then we have discussed about the second law efficiency, which is very important in the context of steam power cycle. I request the students who have joined this session online, or any students, if you have any questions from the module that already you have completed by this time, to post your question in the chat box. You all know perhaps that this session is limited to only 1 hour. So I request you all to post your question in the chat box. I would love to discuss them all. You also know that for this course, like other MOOCs courses, there is a discussion forum, and you are allowed to post your questions. You are allowed to write your doubts in the discussion forum. Teaching assistants of this particular course shall get you back with the answer to those questions. I request all the students registered participants of this course to raise your question or to post your question in the chat box if you have any, and we shall discuss those questions systematically. Steam power module is an important module of this course. As the name suggests, applied thermodynamics, wherein applied part of several thermodynamic processes, thermodynamic concepts have been discussed in this course. Steam power cycle or steam power plants operate on a cycle and or cycles. Those cycles are thermodynamic cycles. I mean, if it is a Rankine cycle, then there are several other modifications of the Rankine cycles. So we have discussed the Rankine cycle. In fact, we have discussed the Carnot cycle. From there, we had tried to discuss the issues or drawbacks associated with the Carnot cycle. That is an ideal cycle or ideal thermodynamic cycle. And then we have discussed about the practical cycle or real cycle, that is the Rankine cycle, simple Rankine cycle, identifying even the problematic parts of a simple Rankine cycle. We have discussed several other modifications needed essentially to improvise the efficiency of the cycle. If we can increase the cycle efficiency, certainly the efficiency of the plant will increase. And then we have also discussed each and individual component, at least the major components, including flow nozzle. In this course, we have identified the process which is there in a particular component. We have mapped those processes in several thermodynamic planes. Then, applying combined laws of thermodynamics, we have tried to estimate either the heat transfer or work output. So heat and work, essentially these two quantities are two different forms of energy. And so we have tried to understand the energy interaction or energy input or energy output from a device, either in terms of heat and work or heat, either it is heat or it is work. We have tried to estimate, and knowing the heat input and work output, combinedly calculating all these, so the net energy input to the cycle and net energy output from the cycle in terms of heat or work, we have estimated the thermal efficiency. We have also solved numerical problems just to understand the conceptual part that we have learned from this course. And we have also understood that by solving numerical problems, it is possible to understand several other important issues which are not otherwise possible to know just from the theoretical part. So I request all the students and registered participants of this course to post your question in the chat box if you have any. You are also allowed to write your doubts to me over email, or you also can post your doubts in the discussion forum. Teaching assistants of this course will get you back with the solutions of those doubts timely. I request the students registered participants of this course kindly post your question in the chat box. You all know that this session is limited to only 1 hour. So I request you all to post your question without any further delay if you have any. If anyone has joined this session or if anyone is having any questions, any doubts, please feel free to post your question in the chat box. The sole purpose of this session is to have some live interaction with the course instructor. So you should use that platform to discuss your doubts and to have direct interaction for any relevant topics of this course. As you know that this course has 2 instructors. My colleague Professor Niranjan Sahu will discuss the remaining modules of this course in the subsequent live sessions. But in this live session, as I mentioned earlier, I am pretty sure that you have already completed the steam power module. This is an interesting module. You know that this module has several practical applications. And we have tried to discuss several aspects to the extent possible, including by solving a few numerical problems to make you understand the conceptual part. Thermodynamics is a very conceptual subject, and this course is applied part of that, conceptual topics. So this course discussed, rather in this course we have discussed the applied parts of the thermodynamics. So essentially, without knowing the fundamental and conceptual part of the thermodynamics, it will be very difficult to understand the applied components. So considering this aspect, initially we have discussed about the basic laws of thermodynamics, which are very important to know, both first law and second law, and combine first and second laws. So these laws are very helpful to understand about the process that takes place across a device of a steam power plant. And then we need to map all these processes in several thermodynamic planes. So we need to understand first the conceptual part. Say for example, whether the process is a reversible adiabatic process or the process is reversible isothermal process. What would be the work done? So all these things, if we need to know the conceptual part of thermodynamics. And we have tried to discuss the basic laws of thermodynamics in the beginning of this course, just to make you understand about the applied processes, applied components. So I request the students who have joined this session today to post your question in the chat box, and I shall be happy to discuss all these questions now. You are also allowed to post your question in the discussion forum. You also can directly write or directly email me about the doubts you will be having on this particular module. Likewise, if you you are also allowed, or you please feel free to write an email to Professor Niranjan Sahu if you have any questions, or if you will be having any questions from the rest of the modules. I request the students who have joined this session to post your question in the chat box. You all know that the session is limited to only 1 hour, and if there is no questions, we will be able to wrap up the session maybe after 30 minutes. I ask all the students or registered student to be precise to post your question in the chat box. Even if you have not joined the session, you can, post your question in the chat box. Or if you have joined the session, you would like to interact with me, I'll be happy to interact with you all. Please feel free to post your question in the chat box. The course Applied Thermodynamics, as I mentioned in the beginning of this session, is an important core course to the students specializing in mechanical engineering, chemical engineering, electrical and electronics engineering, aerospace engineering, and civil engineering. Also, students from power plant engineering or power engineering should know this course, because to them this course is a very important course. So to design several components which are there in a power plant, to design the power plant as a whole, someone should know about the course, someone should know about the modules of steam power engineering, and to design the process, to design the system of a steam power plant, first of all, we need to know the process that occurs in a particular component. We need to identify the processes. We need to map the processes in several thermodynamic planes, and then we can look for further modification, further improvisation needed. I request the students who have joined this session or who are attending this session remotely to post your doubts or question in the chat box to enable me to discuss those questions in this session. In this course, there are several other modules like internal combustion engine, gas turbine, refrigeration cycles, and these modules you will learn in subsequent classes. My colleague Professor Niranjan Sahu will join other 2 live sessions, and he will discuss the doubts and questions you will be having after listening to those modules. I request the students, registered participants of this course, those who have joined the session or attending the session remotely, please feel free to post your question in the chat box. Has anyone joined the session? He or she is requested to interact with me if you have any doubts or questions. This session is limited to only 1 hour. As of now, there is no question. And if I do not find or do not see any question in the chat box, I would like to wrap up the session in another 5 minutes. I request the students or registered participants of this course to post your question in the chat box. As I mentioned, I'm pretty sure that by this time you have completed the first module of this course, that is the steam power module. In this course, we have discussed several facets, several aspects of steam power module, including the recapitulation of basic laws of thermodynamics, identifying several processes, those takes place through several components of a steam power cycle, steam power plant, mapping those processes in several thermodynamic planes, essentially to quantify the thermal efficiency. Thereafter, we have also tried to discuss several modifications. Those are needed to improvise the cycle efficiency. I request the students to post your question in the chat box so that we can discuss those questions now. In the remaining modules of this course, my colleague Professor Niranjan Sahu will join the remaining 2 live sessions, and he will interact with you all to clear your doubts. This session is designed only to have some live interaction with the course instructor. In this course, there are 2 course instructors, as I mentioned before. So you should use this opportunity to interact with the instructor to clear your doubts, to know more about this course. This is not only the platform you can interact with the instructor, you also you are also allowed to email your doubts, questions to the course instructors. Also, there is a discussion forum for this course like other MOOCs courses, and I know that you have already posted your doubts, questions in the discussion forum. Teaching assistants of this particular course will be happy to give response to those questions after knowing them. I request all the students or registered participants of this course, those who have joined the session, or if anyone is attending the session remotely, please feel free to post your question in the chat box to enable me to discuss those questions. You also can email me if you have any doubts or questions. I'll be happy to give response or reply to those emails. As I mentioned in this course, not only we have discussed about the theoretical part, we have also solved several numerical problems just to make you understand about the concept that you have learned through this course. Solving a few numerical problems will make you clear about the conceptual part or several fundamental aspects that you have learned. And solving a few numerical problems will give you enough confidence to know more about this course. And as I mentioned, that to design a steam power plant, you need to know about the steam power cycles, the fundamental or basic cycles that are used to describe the processes in a steam power plant. And as I mentioned that in a steam power plant, there are several components. So we need to know the function of each and every individual component. We need to identify the process that is taking place through each and individual component. We need to map all these processes in several thermodynamic planes. And from there, we can apply combined laws, that is combined first and second laws of thermodynamics to estimate the energy interaction, whether it is heat or work. All these aspects I have discussed for this particular module in this course. If you have any questions, please feel free to post your question in the chat box. As I mentioned that this session is limited to 1 hour only. As of now, I didn't find any question in the chat box. So I'll wait another 30 seconds and then I'd like to wrap up the session for the day. Please feel free to post your question in the chat box. It is not mandatory that you have to raise your question here only. You please feel free to email me if you have any doubts, at least from the steam power module of this course. I'll be happy to give reply to those emails. Since there is no questions in this session, and I'm expecting not to have any further question, I would like to wrap up the session for the day. As I told you, please feel free to email me if you have any questions. Thank you.